In this video we're going to look at trying to find an unknown side when the unknown side is in the denominator of the ratio, and we're going to look at two examples. But first I'd like to consider the following. Consider the equation 10 divided by x equals 2. 10 divided by what equals 2? And I hope you'll agree that the answer is obviously x equals 5. Well, how do we get 5 from 10 and 2? And the answer, I hope you'll agree, is x is 10 divided by 2. In the second example, the x is also underneath. 240 divided by something equals 10. 240 divided by what equals 10? And I hope with a little bit of thought you'd agree that the answer is 24. 240 divided by 24 is 10. How do we get 24 from these numbers? And the answer is clearly 240 divided by 10. So whenever we have the denominator as the unknown, one obvious way to get from the answer of 10 divided by what equals 2 to x equals 5, what we're really doing is simply swapping the places of x and the thing it's meant to be equal to on the other side. If 10 divided by x is 2, then x is 10 divided by 2. If 240 divided by x is 10, then x is 240 divided by 10. So, when we get to examples involving trigonometry with numbers which aren't quite so nice, we still proceed as before, mindful of what I've just been talking about. In this example, we have 71 degrees, 48.5 meters, and an unknown side z. Well, z is clearly the hypotenuse, the side not attached to the right angle, and relative to the 71 degrees, the 48.5 is not attached to the angle. So this is the opposite. So what ratio deals with the opposite and the hypotenuse? And if you cast your mind back to SOHCAHTOA, you'll realize that sine equals opposite over hypotenuse is what ratio we are dealing with. So, writing down the information we know, sine of 71 degrees is the opposite divided by the hypotenuse, which in our case is 48.5 meters divided by the unknown side z that we're trying to find. Use your calculator to find out what sine 71 is. 0.9455. Well, this is the important bit. 48.5 divided by z is 0.9455. Technically, what we're actually going to do is get rid of the division by z by multiplying up. So 48.5 is 0.9455 multiplied by z, and then we don't want 0.9455z, we want z by itself, so we need to get rid of the multiplication by 0.9455. So z is 48.5 divided by 0.9455. And when I do that calculation, I get an answer of 51.3. Actually, all I've done is taken the 48.5 over z equals 0.9455 and swapped over the z and the other number. So 48.5 divided by 0.9455 is equal to z. And we have our answer of 51.3 meters. So now in the second example, relative to the 49 degrees, the side opposite the right angle is the hypotenuse. The side attached to the marked angle 49 degrees is the adjacent, which is the x, and the side not attached is the opposite. So here we have information about the opposite and we want information about the adjacent. So again, thinking of saw, car, tower, the ratio which involves the opposite and the adjacent is tan. So tan 49 is opposite over adjacent, which is 13.2 divided by x. Let's work out what tan 49 is, and the calculator tells me it's 1.15. Realistically, the important piece of information is this. So 13.2 divided by x is 1.15. So multiplying up by x, 13.2 is 1.15 times by x, but I don't want 1.15x, I just want x by itself, so I need to get rid of the multiplication by 1.15, so x is just 13.2 divided by 1.15. Realistically, all I've done here is swapped over the x and the 1.15. I've just changed their positions over, and I have x is 13.2 divided by 1.15, which is 11.47, and the units were centimeters. So whenever we find an unknown side in the denominator, technically we multiply up and then divide back through on the other side, but realistically what it looks like is we simply interchange the positions of the thing underneath and the thing that the ratio is meant to be equal to.